We're going to look now at the opposite to setter functions, which are getter functions. And in the setter functions I had three. I had set x, set y and set xy. But for the getter functions I'm only going to get the x value and get the y value. There's no reason for me to actually get the x and y, not at the moment anyway. We might change our minds later, which I will come to. So to write a getter, we're doing the same sort of thing. Public. Now the return type, which comes next, is not void. It has to be the value of the item we're getting, which is an integer. So public int get x, we pass no parameters, and it's just one simple statement, return x. It's as simple as that. And we can do exactly the same for y. Public int, it's returning a type int, get y, and again just return y. So that's it. Now, might seem like a lot of work, and perhaps we haven't finished yet. Just to represent a point, why can't we just have a simple set of brackets and 0, 0 in them, rather than have to go through all of this coding with all of these setters and getters? Well, you don't need all of them, number one. That's down to you. So for example, I didn't need three constructors. I could just have had the one constructor, this one, to set them both, but I'd have to give both when I created it. Coming back here, having this one, if I was drawing a graph of y equals x, then because y and x are always the same value, there's no real reason to pass anything but a single value, because if I use this one, it would be 2, 2, 3, 3, 4, 4, 5, 5. So it just shortened it, so I could have a little loop for I equals 1 to 10, create a new point for I, and I had the set of coordinates throughout. I seem to have an error here, so I'm just run the program, see what's going on. No, that's fine. But it does seem like it's a lot of work for something really simple. But what you've got to remember is you're creating a new data type. You're creating a point. You don't know how it's going to be used. You might have some idea for your own program, but you might be creating this for somebody else. You don't know how it's going to be used or where it's going to be used. And you're really trying to think of just about everything you can do with a point, to give maximum flexibility for the person who uses your class. So in the next video, what I'm going to do is show you a way of displaying. So at the moment we've got, when we run it, that's fine. It just tells me I've built successfully. But if I want to view the values, P, P1, P2, or the points, the way to view something is by writing a system dot out dot println, and in there put the value I want to print. So I want to print P. I can write that again. System dot out dot println P1, and finally system out println P2. If I have these three statements which are going to print values down here, you would expect to see 0, 0 for that, 2, 2 for that, and 3, 4 for that. And strangely, that's not what we get. There we go. All we get is the fact that we have a pointer to a reference in memory where these variables are held. What we need to do is get that and print it out. Now, one way that we could do it is we could do print P dot get x, and that would give us our x value. So if I now run that, we can see that we've got the value 0 here, which was the X that we set up. If I want to see the Y, then if I take the print line out, well, let's copy all of that to begin with. And add another statement here for print Y. And if I change that to print, they will be on the same line. So if I now run that, what have I got? Okay, I run that, we get this 0 and 0 on the same line here. It doesn't really look like a coordinate for our use. In the next video I want to show you a standard method that exists in every object, or virtually every object, which helps us print these values out to the screen. But we've called these values now, get X and get Y for the point. We could do the same for P1 and P2, and we could see what values the X's and Y were set at. So in the next video we're going to look at a nicer way of displaying our results.